person of mass 50 kg stands on a platform. A person is standing on a platform and the mass of that person is given to be 50 kg. The platform oscillates with a frequency of 2 Hz. This platform is oscillating with a frequency of 2 Hz. Okay. The amplitude of oscillation A is 0.05 meter. Calculate the maximum and minimum weight of the person recorded by a machine of the platform. यहाँ पर सब जो वेट मशीन है, वेइंग मशीन है, तो इसमें मैक्सिमम वेट कितना रहेगा और मिनिमम वेट कितना रहेगा. One thing he forgot to give there is that the platform is oscillating vertically, not horizontally. Platform is oscillating vertically. So what happens here now? Suppose this is the mean position of the platform. When the platform is going up, its acceleration is downwards. Acceleration in S.H.M is towards mean position. So when he is moving up, his acceleration due to gravity is downward, and acceleration due to S.H.M is also downward. So there will be reduction. The net acceleration will be G minus A. And where will be this reduction maximum? At the top position. जब यहाँ पर पहुंचेगा तब acceleration maximum होगा. As the particle moves away from the mean position, the distance goes on increasing and the acceleration also goes on increasing. So at this point, at the upper extreme, the acceleration will be maximum. So the reduction will be maximum. मतलब यहाँ पर उसका weight होगा minimum, because weight is mg. Now g has become g minus a, so here the weight will be minimum. Similarly here, the effective acceleration will be g plus a, because the acceleration of S.H.M is upward and acceleration due to gravity is downward in opposite directions. So the net acceleration will be g plus a. Therefore, the weight will be maximum here. And you have to find that maximum and minimum weights. So for finding that maximum and minimum weight, you should know the value of A, the acceleration. Actually, A we are using here for amplitude. So we can use capital A for amplitude, or you can use small a for amplitude and ACCN, acceleration, for this acceleration of S.H.M. So the acceleration in S.H.M you have to find out. Frequency is given, amplitude is given. What is your formula? How can you find the acceleration? So the frequency is given, means omega is given, right? So acceleration max, maxifying करना है ना हमको, either here or here, the acceleration is max, is a omega square, amplitude into omega square, or you can say a into 4 pi square n square. So acceleration, now I'm calling it small a, is amplitude, that is 0.05 into 4 pi square into n is 2, 2 square is 4, correct? That is equal to 4 into 0.05, 4 5s are 20, means 0.2, 0.2 into 40, that is 8. So acceleration is 8 meter per second square. So at the topmost position, the weight will be minimum, which is equal to m into g minus a. M is 50 into 10 minus 8, that is 2. So that is 100 Newton. That is the minimum weight recorded, and maximum weight recorded will be m into g plus a, that is equal to 50 into 10 plus 8, that is 18. So that is your maximum and minimum weight. 100 Newton, I'm sorry, I forgot. 900 Newton, approximately. 100 and 900 are the approximate answers. Springs of constants k, 2k, 4k, 8k, dot 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 means up to infinity. Springs of force constants k, 2k, 4k, 8k, dot 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 up to infinity are connected in series. These are connected in series. Okay. A mass capital M kg is attached to the lower end of the last spring. Mass is capital M, which will be in simple harmonic motion. And the system is allowed to vibrate. What is the time period of oscillation? You have to find capital T. Now we know that capital T is 2 pi under root M by K. M is capital M and K will be effective force constant. Now these springs are connected in series. So first we'll find out effective force constant. So 1 upon K effective will be equal to 1 upon K plus 1 upon 2K plus 1 upon 4K plus dot dot dot. Right? Because effective force constant in series combination is 1 by K1 plus 1 upon K2. 1 upon K effective is 1 upon K1 plus 1 upon K2. So we add all this. That is equal to, if you take 1 by K common, what remains inside? 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 onwards. What is this? So, what is this? This is geometric progression. You know geometric progression, and you know that the sum of the geometric progressions, the sum of all this is A upon 1 minus R. Geometric progression, A is 1. R means common ratio. Here, what is common ratio? 1 by 2. So, this is equal to 1 upon K into A upon 1 minus R, that is 1 by 2. That is equal to 1 by K into 1 upon 1 minus half is half. So 2 goes to numerator. So that is 2 upon K. So 1 upon K effective is 2 upon K. Means K effective is K by 2. The effective value of force constant is K by 2. So to find T now, T will be equal to 2 pi under root M by K. That is equal to 2 pi under root M is capital M upon K is K by 2. So this is the periodic time of oscillation of the mass capital M. A block of mass 5 kg, a block of mass 5 kg executes simple harmonic motion under the restoring force of a spring. स्प्रिंग को ब्लॉक अटैच किया हुआ है. The amplitude and time period of motion are 0.1 meter and 3.14 second. Amplitude is 0.1 meter and period is 3.14 second. Fine. Find the maximum force exerted by the spring on the block. You have to find F max is equal to what? Maximum force exerted by the spring on the block means restoring force maximum. You have to find out. The restoring force होता है kx in magnitude, right? Magnitude of restoring force is kx. Maximum restoring force means x will be replaced by a, amplitude, because restoring force will be maximum at the extreme position. So maximum restoring force will be Ka. K is not given here, but we know that K is equal to m omega square. K by m is equal to omega square, or K is equal to m omega square into A. That is equal to m into omega is also not given, but T is given. So omega square will be 4 pi square upon T square, 2 pi by T into A. That is equal to, mass is given to be 5 kg into 4 pi square, 44 into 10, amplitude 0.1 meter upon T square is pi square again. So this 10, 10 gets cancelled. 5 fours are 20, 20 into 0.1, that is 2 Newton. So the maximum force exerted by the spring on the block will be 2 Newton. A body of mass 1 kg, a body of mass 1 kg is suspended from a weightless spring having a spring constant 600 Newton per meter. Spring constant 600 Newton per meter. Another body of mass 0.5 kg, this is M1. Another body of mass 0.5 kg moves vertically upward with a velocity of 3 meter per second. Okay, velocity of that body is 3 meter per second. Fine. Hits the suspended body and gets embedded in it. Okay, here is a spring and a body of mass M1 is attached to that spring. The force constant of the spring is K, that is 600 Newton per meter. What it says, another body of mass M2, suppose 0.5 kg, it moves upwards with a velocity 3 meter per second, strikes it and gets embedded. जाके उसको क्या हो जाएगी, वो चिपक जाएगी. It moves up and gets embedded. Gets embedded means it remains stick to it. Okay, stuck to it. It remains stuck to it. So it moves up and gets embedded. Okay, fine. Find the frequency of oscillation. You have to find the frequency of oscillation and the amplitude of the system. Amplitude of system means when body moves up, strikes it, तो इस पर force exert हुआ. Due to this, now both the bodies will start oscillating, performing simple harmonic motion, and you have to find the amplitude of that. So frequency is 1 upon 2 pi under root K by M. Reciprocal of periodic time, T is 2 pi under root M by K. So M is 1 upon 2 pi under root K by M. That is equal to 1 upon 2 pi under root K is given to be 600 upon M will be M1 plus M2, because both the bodies are oscillating together. Second body gets embedded into it, चिपक जाएगी उसको, means both the bodies are performing simple harmonic motion. So M will be M1 plus M2, that is 1 plus 0.5, 1.5, correct? Or that is 15, and this is 6,000. 15 ones are, 15 fours are. Root of 400 is 20. So this is 20 upon 2 pi, that is 10 by pi, or 3.2 approximately. Okay, 3.2 approximately, this much hertz is your first answer, the frequency of oscillation. Now you have to find the amplitude of that SHM. उस SHM का आपको amplitude भी find करना है. Now how can you find the amplitude of SHM? Okay, एम्पलीट्यूड ऑफ SHM फाइंड करने के लिए हमारे पास इंफॉर्मेशन क्या क्या है? From the conditions of the problem, you can think that here it is possible to use law of conservation of momentum, 11th standard. So the total momentum before collision is equal to total momentum after collision. Before collision, M1 was stationary, M2 was moving. So total momentum is only momentum of M2. So initial momentum M2V, mass of the second body and its velocity. This is the total momentum before collision because M1 was stationary, is equal to total momentum after collision will be the mass of M1 and M2 combined mass into their combined velocity, isn't it? So the total momentum after collision will be mass into velocity of the combination or velocity of the combined mass. Using this, M2 is 0.5, velocity is 3, is equal to M1 plus M2, that is 1.5 into combined velocity, right? 0.5 into 3 is 1.5. So 1.5, 1.5 gets cancelled. The combined velocity is 1 meter per second. So when the second body strikes it, the combined velocity of the two bodies is 1 meter per second. Now due to this, it gains kinetic energy. Now concentrate carefully. When this M2 strikes M1, M1 is here. When it strikes M1, it moves up, suppose up to here. Then it will come down and it will perform oscillation like this. So this position is the mean position of SHM. M1 की जो equilibrium position थी, stationary position थी, that is mean position of SHM, means the velocity here is the maximum velocity, isn't it? Means the energy here is maximum kinetic energy. So this is the maximum velocity, and at this point the energy is maximum kinetic energy. The total energy is in the form of kinetic energy. Now when it strikes here, it moves up. As it moves up, the kinetic energy goes on decreasing and potential energy goes on increasing. And here the total energy is now in the form of potential energy. So the kinetic energy at this point gets converted into potential energy at this point. So Ke max is equal to Pe max. Ke max is half M1 plus M2 V square, that is Vc square, the velocity of the combination. So Ke max is half M1 plus M2 Vc square, and that gets converted into potential energy, which is half M omega square. X square will be now A square because here the displacement is maximum amplitude. So this half gets cancelled, and obviously this M is M1 plus M2. So this M1 plus M2, M1 plus M2 gets cancelled. So omega square is equal to Vc square upon A square. I'm sorry, we have to find out A. So A square is equal to V square upon omega square. So A square will be equal to V square, means Vc square, that is 1 upon omega. Omega is 2 pi n whole square. So omega square is 4 pi square n square. That is equal to 1 upon 4 pi square into, how much was n? N was 3.2 approximately. So its square, you can take 10, no problem. So pi square into 10, 100, 1 upon 400. So a square is 1 upon 400, means a is equal to 1 upon 20, or you can say 0.05 meter approximately. 0.05 meter approximately. And the exact answer is also 0.05 meter. So you got the exact answer. A simple pendulum consists of a small sphere of mass m suspended by a thread of length L. The simple pendulum has thread of length L and a sphere of mass m. Okay. The sphere carries a charge q, positive charge q. इस sphere पर there is positive charge q plus q. Okay, fine. The pendulum is placed in a uniform electric field of strength E, directed vertically upwards. Okay. This sphere is kept in uniform electric field which is directed upwards. Fine. With what period will the pendulum oscillate? What will be the periodic time of oscillation of this pendulum? Okay, will oscillate if the electrostatic force acting on the sphere is less than the gravitational force. मतलब जो electrostatic force है वो gravitational force से क्या है, कम है. So what will be the period of oscillation? For a simple pendulum, the period of oscillation is 2 pi under root L by G. Direct formula. G is the acceleration due to gravity. But here, in this case, the effective acceleration is going to change because the weight of the bob is acting in the downward direction, and due to this electric field, a force will act on the bob. In which direction? Upward direction. Force due to electric field will act in the upward direction because the bob is carrying which charge? Positive charge. And the force on a positive charge, if a charge is kept in the electric field, when a charge is kept in the electric field, the force on the positive charge is in the direction of the field, and force on the negative charge is in the opposite direction of the field. Here, the sphere is carrying positive charge, means the force due to electric field will be in the direction of electric field. So, weight is acting downward, force due to electric field is acting upward. Due to that, the net weight will decrease, so acceleration will also decrease. So, net force on this sphere, on this bob, will be its weight mg minus force due to electric field, that is QE. Remember this, electrostatics, force on a charge Q when it is kept in the electric field is how much? QE. So that is equal to M, mass of the bob. Is it given? No. So mg minus QE as it is. So net acceleration will be mg minus QE upon m. Acceleration is force upon mass. So net acceleration will be mg minus QE upon m. Therefore, the periodic time will be 2 pi under root L upon, in place of g, it will be effective acceleration, that is mg minus QE by m. So this will be the periodic time of oscillation of that pendulum. तो हम रुकते हैं यहाँ पर. प्रैक्टिस करो, जितने क्वेश्चन अभी हुए हैं उनको फिर से एक बार सॉल्व करो. सो हैव अ नाइस टाइम, गुड डे, बाय बाय.